and so we've been using those terms of boiling, freezing, melting. So I wanted you to be able to interpret a graph, and so you're looking at a phase diagram which has the different phases, and you can see what's making the difference in the phases is as the pressure increases, and along the x-axis we've got the temperature, and so as we increase the temperature we start to see some phases changing. So this is really an easy thing to understand, but some students have trouble because this one's all nice and listed for us. So we've got solid here and liquid here and gas here. So if I ask you what's happening right there, you would tell me it's a solid. If I ask what's happening here, you would say it's a liquid, etc. So that's really easy. When it's harder to understand is when those words, solid, liquid, gas, are gone. So if solid were not here and liquid were not here and gas were not here, would you still understand those words? And that's what I want you to be able to understand there. And we actually can adjust. Most of the time we think about adjusting the temperature of something to make it change states of matter, but you actually can adjust pressure as well. And we're moving on next unit to gases, so pressure will play a part. And so if you pressurize it enough, you can actually change states of matter. Believe it or not, we can get water to boil like 80 degrees if we apply enough pressure. All right, and then we're going to talk about this point here and this point here. So let me go to the next slide. And you can kind of see it looks a little bit more complicated, but this one's explaining the states of matter that happen as you transition from one to the other. Remember, this is where solid was, this is where liquid is, and there's where gas is. So if we go from a solid to a liquid, of course we would be melting, and if we go from a liquid to a solid, we would be freezing. On this line here, they call it equilibrium, which means where both states of matter are existing at the same time. And what that means is that's the point at which it's transitioning, such as the melting point or the freezing point. For example, if we were looking at here, this would be I've just put it there. When we talk about things freezing and melting and boiling, we usually do that in terms of 1 atmosphere. So if you change the pressure again, you're going to change that point. But the standard, for example, water boils at 100 degrees. Well, that's at 1 atmosphere. If we go up in Colorado where it's not as much atmospheric pressure, you're going to see water boils around 96 or so, depending on where you're at in Colorado. So usually it's 1 atmosphere. So if it asks for a point, then you're reading a point on the line, such as this may be the melting point. Like say if this was 1 atmosphere and I say, what is the melting point? I got it. I know it's freezing right there, but if you go that direction. So the melting point and the freezing point at 1 atmosphere are the same. For example, water melts at 0 degrees and it also freezes at 0 degrees. If I were doing this one up here, this would be like 1.2 atmospheres or so. This point here would be the melting point and the freezing point. So even though they've got them above one another, anytime up here, that's the melting point and freezing point. We'll say if that were like 2 atmospheres, etc. So it's just a point on the line there. So types of questions that I'll ask would be, I would put letters like A and B, and I'll say what happens if something goes from A to B, and you would have to know, well, A is a solid and B is a liquid, so it would be melting. And if I go, what happens if it go from B to A? And then you would say that that's freezing. And then I would say, well, what's happening at C? You could say the melting or freezing point there. So those are the types of questions you would see. So you need to understand melting and freezing, which we've talked about those, and those are just common sense ones. Condensation and vaporization, if it gets hot enough, it's also known as boiling. So the difference between evaporation and boiling, it's still going for evaporating is going from a liquid to a gas, where boiling is also a liquid to gas, but boiling requires an increased temperature. Some things have a very low vapor pressure, like gasoline. If you get it on the ground, it's going to evaporate very quickly. So we just use the general term vaporization for when something goes from a liquid to a gas, and that covers both boiling and evaporation. So that's why you're seeing that word. So we could say boiling point as well. That would be fine. So as we go from a liquid to a gas, vaporization or boiling, and then as we go from a gas to a liquid, that's just condensing. It's condensation there. And then these two terms are these are again physical changes. We've talked about these terms before in physical changes. When something goes from a solid to a gas, it skips liquid altogether. That's called subliming. That's what carbon dioxide does in dry ice. It starts out as a solid and it goes straight to a gas. And we have talked about that term when we did physical and chemical changes. And deposition. Deposition is when it goes from a gas to a solid, such as frost depositing on your windshield. It started out as a gas and it ended up as a solid. So these are vocabulary words that you do need to know. So now let's talk about those points. Just looking at that, triple point. Triple point is the point at which all three states of matter exist at the same time. It's a really cool point. I used to be able to do this with my high schoolers with dry ice. Dry ice is so expensive I don't get a chance to do it anymore, but you take a small piece of the dry ice, and if you can get the temperature and the pressure just right, you can actually see solid, liquid, and you can feel the gas pressure building up. We do this as in a little bulb. So triple point, again, the point at which all three states of matter are existing. And then right here at the equilibrium line between the liquid and the gas. So critical point. This is when all the intermolecular forces of the liquid have kind of, not all I guess I should say, because there's still some London, there's always some London, but most of the intermolecular forces that are holding it together as a liquid have been broken. So this is the pressure and temperature at which it can only exist as a gas, because we've broken all those intermolecular forces. So past that point there on the graph. So I want you to be able to read a phase diagram graph. So if these words were not on there, super easy. And that's what your questions, your attendance questions are going to be on, is being able to read a graph.